All right, so we've learned about box plots. Now let me tell you about an important part of the box plot, which is the interquartile range, and how that helps us to determine outliers or extreme values in our data set. So the interquartile range is basically the size of the box in our box plot. It just shows the range of the centermost half of our data. That's the two quarters that are inside the box of the box plot. It just shows how spread out those two quarters are together. Let me show that to you this way. Here's the box plot that we created in our box plot video. Um, you have the two whiskers and the two boxes in the middle. Essentially, what we're doing is we're ignoring the whiskers and we're saying how wide is the box itself. And we do this simply by taking the difference between the third quartile and the first quartile. In this data set we used for this graph, we determined that the first quartile was 2.5 and the third quartile was 7. So what's the difference between 7 and 2.5? The difference is 4.5. So the interquartile range is 4.5. In other words, that's the width of the two of our box in the box plot, of the two innermost quarters of the box plot. All right, now that's helpful, and it is very helpful information. But in addition to telling us how spread out the centermost part of our data is, it's also a key indicator for determining outliers. Now, outliers are extreme values, so extreme that they are unreasonable. We can use the interquartile range to help us determine where the outliers are. So essentially, we're saying this middle half of our data is good data. Let's take, some distance away from that box and say a distance from that box is good. Anything beyond that, those are a little extreme. So what we do is we take our third quartile and add 1.5 times our interquartile range, and anything beyond that is an outlier. Likewise, we take our first quartile and subtract 1.5 times our interquartile range. Anything beyond that is an outlier. But anything between those 2 points is good. Let me demonstrate this to you here on Desmos. So we have our interquartile range, which is 4.5. If we multiply that by 1.5, that gives us 6.75. So essentially, I am going to start here and I'm going to say, let's go 6.75 units up here. And that's good. That's good data. Likewise, from our first quartile, we go 6.75 units down from there. And that's all reasonable data. Okay. But what about beyond that? Well, beyond that, that's the region where it gets a little bit extreme. And so we say, no, those are outliers. Let's not worry about those. Okay. All right. So that's how you find it. You take the interquartile range, multiply it by 1.5, 1.5, and then add that distance to the third quartile, subtract that distance from the first quartile, and that gives you a much broader range for your reasonable data. Anything beyond that are your outliers. Now, in this particular example, all of my data is within this reasonable data range. Let me give you another example here where that is not the case. We did this as well. We created a box plot before for the second data set, and let me quickly shift over there to be able to see it. Oops. Oh, you know what? Let me just do this. This is going to be faster. There we go. Okay, there we go. In this data set, just as a reminder here, let me pull up. I've got it right there. Our first quartile is 21.94. Our third quartile is 22.39, which means the range, the interquartile range, is the difference between those two numbers, which would be a difference of 0.45. 0.45 is our interquartile range. So let me go ahead and put that up here. There's the interquartile range. It's the size of the box, difference between Q3 and Q1. That range in this example is 0.45. Now, if I take 0.45 and I multiply it by 1.5, I get 0.675. Okay, that's how far we can go in either direction. So it's not very far. 0.675, that's less than 1, which means that's about as far as I can go to the left, and that's about as far as I can go to the right. Let me go ahead and put those limits up for you. Okay, that's as far as we can go with reasonable data. That's 1.5 interquartile ranges above Q3, 1.5 interquartile ranges below Q1. But notice that there is a data point that's out here outside of my reasonable data. It's in the outlier range. What do we do? Well, what we do is every point that is outside in those outlier regions, we indicate those with circles, and then we re-indicate the new maxima and minima in our graph. Here is a similar graph. You see the minimum is the same, the box is the same, but this one point, this one outlier is indicated with just a dot. And then the next highest value becomes our new maximum. That is our modified box plot, or you could say it's a box plot excluding outliers. Both ways are good. Okay, that helps us understand a little bit more there about the interquartile range and how to determine outliers.